Hello, my name is Viacheslav Zgonnik and I'm managing the startup Natural Hydrogen Energy. I'm working on the topic of natural hydrogen for many years already, and the part which fascinates me the most is the possibility that there are large portions of primordial or so-called deep-seated hydrogen are still stored inside of our planet. So today I will present you the current knowledge in this topic, and you will see that it is actually possible that our planet is hydrogen rich inside. You've just seen a presentation about one of the most studied mechanisms of hydrogen formation, which involves reaction of water with ultra-basic rocks like olivine, for instance, and hydrogen is a byproduct of that reaction. And you will see today more presentations about that mechanism. But I would like to present you the possibility that the Earth's core and Earth's mantle are enriched with hydrogen. And unlike the surface of the Earth, where we can take samples and make measurements, the problem of studying the Earth's interior that there is no sample from the Earth's core. And only we can do is to build models and guess what could be the composition inside of our planet. The idea that Earth's interior could be enriched in hydrogen has been proposed almost 100 years ago by Vladimir Vernadsky. He is one of founders of modern geochemistry. You can see his portrait here on the largest bill in Ukraine of 1,000 hryvnias. He was one of co-founders of Ukrainian Academy of Sciences and its first president. And in 1933 he wrote that he believed that hydrogen should be present inside of the Earth, stored in form of metal hydrides. He didn't have any proofs for that at that time, but the idea was very clever based on his observations working many years with surface hydrides like water or hydrocarbons. Unfortunately, this idea didn't attract any attention and remained unknown for decades till 70s when Vladimir Larin published his works proposing that Earth was primordially hydrogen rich. And I will come back to his theory later, and now I need to explain why those ideas didn't attract more attention. You can see on these pictures the steps of the early history of the Earth, which all involved high energy impacts and melting during the accretion of the Earth, during the moon forming impact, and during the late heavy bombardment event. All of these events were passing with high energies, and it is considered that the Earth's material has been melted during these steps. In such case, it is impossible to have light elements in large quantities in the Earth's composition because all of them should have been degassed a long time ago during the time of formation of the Earth during those steps. This idea of the structure of the Earth has been influenced by two observations. First, from seismic data, we knew that Earth has a dense core and a density which is close to metal density. And also from the observations of meteorites, we knew that there are several types of meteorites. There are metal type and there are rocky type, and there is intermediate type which is composed both of minerals and metal. And the Earth's composition has been suggested, which is very logical, to follow the same process as when iron is produced in furnaces, when liquid metal goes to the bottom by the effect of gravity and rocks flow on the top of this metal. However, the problem with that idea that there is a core density deficit. So there is something lighter inside of the Earth's core. We don't know what it is exactly, but from seismic observations and from experiments in the lab, we know that there are approximately 10% of difference. The Earth's core is 10% lighter than it should have been if it was a simple iron-nickel alloy like in meteorites. So there is something else in the Earth's core. Any solutions must satisfy four criteria. First, the light elements which we put into the core, they should be present in the original Earth-forming material before they are secreted. then the compounds between those light elements and heavier elements, they should be stable and the conditions of pressure and temperature of the Earth. Those light elements, they should be siderophile. This means they should be soluble in the metal phase and not be exposed like in previous picture, like rocks are exposed from liquid metal. And also, the most important, that the overall bulk composition of the Earth must be compatible with the original building blocks for the Earth. Despite the fact that hydrogen is the most abundant element in the composition of the solar system, our galaxy, or the entire universe, it was not considered to be a good candidate for light elements inside of the Earth, because the main idea was that all of the volatile elements, or vast majority of them, degassed during the accretion step I just showed you in the pictures. And also there was no data, and it was the idea that hydrides of metals, especially iron hydrides, cannot be stable at high pressures, high temperatures, which are inside of the planet. And actually in 1977, Stevenson published a paper in Nature journal providing theoretical backgrounds and showing actually, yes, hydrogen is a good candidate for core density deficit problem, and it is possible that it is present inside of the Earth. And then 3 years later, there was an experimental study published showing that iron hydrides are actually stable at high pressures and high temperatures, which are close to the conditions which should be inside of the planet. And just 4 years later, Fukai published again in Nature the idea that hydrogen could be incorporated in the Earth's core, and he explained this by the reaction between metallic iron with water, which gives two compounds, iron oxide and iron hydride, and hydride becomes liquid. It sinks into the Earth's core because it's soluble in metals and it is dense, and then iron oxide remains in the mantle. And this work provided the background for the series of papers exploring this idea. A decade later, Okuchi published this time in the journal Science the results of experiments showing that actually hydrogen is partitioning into molten iron at high pressures, temperatures, and that could explain the mechanism how it get there inside of the Earth. So this idea is explored largely. There are a series of papers. I'm providing just here a couple of examples, and you can see the article of Tagawa and other authors, which has been published last year. So the research on this topic continues. Here are a couple more examples of other works which are proposing that hydrogen could be present not only in the Earth's core but also in its mantle, and they provide mechanisms to explain how it was incorporated into mantle and delivered there. All these works and the works I cited previously, they are sort of piggybacking the idea that hydrogen is incorporated in the Earth, but they take as the basis the standard chondritic model of the Earth composition. And in next slides I will show you actually that there are ideas proposing that the Earth could have different composition and it is compatible with existing observations. I'm going back to the works of Vladimir Larin, whom I mentioned in the beginning of this presentation. 30 years ago he published this book, which is called Hydridic Earth, and which provides the new geology for the planet, which was enriched with hydrogen since the beginning. He proposes that the composition of the Earth could be different, overall composition, and that the hydrogen is the main element which plays the key role in the geology and geodynamics of the Earth's processes. And here in the middle you can see the comparative schematics of the model he proposed for the Earth's composition and the traditional model, and you see that there is a large difference due to presence of high amounts of hydrogen in the hydridic model and the lack of oxygen. And this book is available for download. There is address below, and I highly recommend to get it and to read it because it's very thought-provocative, and I believe that the picture of Vladimir Larin will be one day on a currency bill. Just a couple of months ago, in the January of this year, Hervé Toulouat and I published a paper in the Astrophysical Journal which reprises the ideas proposed by Vladimir Larin, and we used the concepts of statistical physics to create a model, and Hervé created a series of equations which allow to calculate what was the bulk composition of the Earth and the moment of its formation. And according to the conclusions of this work, hydrogen is the main element in the composition of the Earth. It was there, and it is possible that it formed the covalent compounds with the different elements, and about 4% of initial weight of the Earth was hydrogen. And here on the right side of the slide you see the comparison between the traditional model and the new proposed model, and you see that there is a 3 orders of magnitude difference in hydrogen content. Our estimate of 4 of 8% for the bulk of the Earth is very close to what Vladimir Larin proposed in his works. You can see these numbers in this table, and also you can see the other works proposing this idea that there is a large quantities of hydrogen inside of the Earth's core. And you can see in this table there are 2 columns, the works citing the initial content of hydrogen in the Earth and also the current content of hydrogen inside of the Earth's core. You can see that there are about the same order of magnitude. However, the current estimates are lower. They range between 0.25 and 2%, and the average is 0.76% of weight of hydrogen inside of the Earth's core, which allows to explain the 10% core density deficit. You can see that these papers were published in large and known journals, and there are many groups working on this idea. Let's try to understand how big is that number, because when we look like that at the first glance, 0.76 doesn't seem like much, but in absolute value it represents 1.4 times 10 to 19 tons, and only 1% of that amount could cover the entire humanity energy needs for 42 million years. This is huge number of planetary scale of hydrogen reserve inside of the planet. But the question arises, can we get this hydrogen? Because it's great that it is there inside of the Earth, but can we produce it? Can we use it? I believe the answer to this question is yes, and I will explain you why. Here is the table with numbers from my review I published a couple of years ago, which provide the annual flux of geologic hydrogen on the planet. And what is interesting, and you can notice that these estimates are increasing approximately by 1 order of magnitude every decade or so. And the number I provided in the review for the total flow of hydrogen in nature from geologic sources is also 1 order of magnitude higher than the previous estimate, and it is equal to 23 million tons of hydrogen per year. But then I also propose that this number is most likely not high enough, because the number of works studying natural hydrogen are still relatively low, and there are no works which account to diffusive flow of hydrogen, for example from recently discovered hydrogen seeping features. And let's try to estimate what could be this number. We can actually do that if we take the numbers from the previous table I showed 2 slides ago. We know what was hydrogen content in the bulk Earth and its formation, and we have the estimates what's the hydrogen content inside of the Earth today. If we take the difference between these 2 numbers, so the initial content was 4% by weight, and the average content today is 0.24% for the global Earth, not for its core. And then by making the difference and by dividing this by number of the years, we come to conclusion that the annual flow of hydrogen is actually 50,000 millions of tons per year, which is 20,000 times higher, or 3 orders of magnitude higher than the estimate we have today. So of course the flow of that hydrogen could have been different during geologic times, most likely it was higher at the early times of the Earth, and now it could be lower, but we actually don't know exactly. There is still lack of research in this direction, but we have at least a directional number of what could be the annual flow of hydrogen on the planet. And if we compare it to the current energy consumption, it is one order of magnitude higher than the current consumption, because it is 3.5 billions of tons of hydrogen equivalent, and here we see the number of 50 billions of tons of hydrogen. So these are great news for all of us. In conclusion, hydrogen is the most abundant element in the solar system. It is logical to admit that it should be much more widespread on Earth as well. And I've showed you on direct examples that the many works suggest that actually, yes, Earth's interior is enriched with hydrogen. And the reservoir of that hydrogen is of planetary scale. It is incredibly big. And what is great for us, that the composition of those hydrides stored deep inside of the Earth could sustain a portion of the observed hydrogen flux on the surface of the Earth. What portion, it is difficult to say today. More studies are necessary, and we will certainly discover that in the future. What is interesting to note, that the idea that the composition of those hydrides must sustain a flux of hydrogen allowed Vladimir Larin and his son Nikolai to discover those hydrogen seeping features, which are now widely studied by the community. And maybe the final remark, that the flow of hydrogen has impact on many natural processes. It has impact on atmosphere, on soil chemistry, on microorganisms living in the deep earth, and so on. There are a lot of things to study, and this is extremely fascinating, very interesting topic, and I'm sure that we will have much more interesting discoveries in the future. And finally, because I am of Ukrainian origin, I was deeply shocked by what is happening today in Ukraine, by this inhuman war which came to my homeland, and by all the destruction, by all the losses of human lives. And it was difficult for me to work last month and making this presentation. And I would like to say thank you to all of you supporting Ukraine. It's very important for all the Ukrainians, the support of international community, and a special thank you for all of those who helped in any way. And please continue. Ukraine needs your help, and I hope that this war will end soon, and Ukraine will have a peace, and which allow maybe one day to develop its potential for natural hydrogen. Who knows? Thank you for your attention, and I will be happy to answer your questions.